Hello, good day, viewers. You're welcome to my class. Today, we shall solve questions on the calculation for relative molecular mass of different compounds. So, to begin with, another name for relative molecular mass is also known as the formula mass. And in simple terms, the relative molecular mass, that is the R.M.M, or also the formula mass, is defined as the sum. When we mean sum means what? Addition, right? So the sum of what? The relative atomic mass of all the atoms that are present in one molecule of that substance is what we call what? The relative molecular mass. Okay? So we are going to solve some mathematical problems to see or to know, to learn how to solve or how to calculate relative molecular mass of different compounds. So let's start with the first one here, which says calculate the relative molecular mass of limestone. And the formula for limestone has been provided, which is what? CaCO₃. All right, so CaCO₃ is a formula for limestone, and we have been provided with the what? Atomic mass of each element present in the compound. We have calcium, carbon, and oxygen. So we have carbon given as 40, carbon as 12, oxygen as 16. So viewers, if you have watched up to this point, thank you for watching. If this is your first time coming across my video, kindly click on the subscribe button and turn on the notification bell so that you will be notified anytime I post a new video here on this page. And anytime I go live, you also get the notification. So let's get started. So just as we mentioned, to calculate relative molecular mass of any compound, it means we are taking the sum of individual what? The relative atomic masses of each element. So in CaCO₃, which is the compound we are solving for, the individual elements here, we have calcium. We have one molecule of calcium here, plus we have one molecule of carbon, that is C, plus oxygen, which is what? 3. So now we are going to write out their individual what? Atomic numbers, so atomic masses. Calcium has an atomic mass of what? 40, plus carbon has what? 12, plus oxygen, which is 16. But in this case, we have to multiply the 16 by 3 because we have a 3 here attached to the what? To the oxygen. So multiply this by what? By 3. So simplifying, we're going to be having what? 40 plus 12 plus 16 multiplied by 3 gives us the value of what? 48. 40 plus 12 is 52, and 52 plus 48 gives us 100. So we have the relative molecular mass of limestone as 100. The SI unit for relative molecular mass is gram per mole. Okay, so we have the relative molecular mass of CaCO₃ as 100 gram per mole. So let's solve another question. So the next question here says, calculate the formula mass of calcium trioxonitrate 5. And the formula has been provided, which is CaNO3 and 2 here. So this is calcium trioxonitrate 5, okay? So we have been provided with the what? Atomic mass of each element, individual element in this compound. So you know it's formula mass, and remember I said formula mass also, another name for relative molecular mass is also formula mass, right? So let's do this together. So the formula mass, or we can say the relative molecular mass, is equal to the sum of individual elements. So the first element here we have calcium plus nitrogen. Everything we have in a bracket here is affected by these two. These two we have here in this subscript, okay? So now this nitrogen here indicates that we have 2 nitrogens here, plus the next element here is what? Oxygen. Okay, the oxygen here is attached with a what? A 3. They will multiply by the 2 here. So now this becomes calcium plus nitrogen, N2 plus oxygen. 3 times 2 gives us 6, right? So now let's substitute in the values of their what? Atomic masses. Calcium is what? 40 plus nitrogen is 14, but we're going to multiply by 2 plus oxygen, which is what? 16, and we multiply this by 6. So let's simplify this. This is equal to what? 40 plus 14 times 2 gives us 28 plus 16 times 6 gives us 96. So summing up all these values, we're going to have a total of 164 gram per mole. So this is the relative molecular mass of calcium trioxonitrate 5. Okay. So viewers, let's try an activity. Okay. You try the activity and drop your answer in the comment section. So viewers, you drop your answer. This is the formula for lead tetrioxide, which is Pb3O4. Drop your answer in the comment section and see you in my next videos. Bye for now.